This lesson is about inverse functions. Let's review some definitions. First, if a function takes the input a and computes the output b, then an inverse function would take the input b and compute the output a. Thus, an inverse function will reverse the flow of input-output of the original function. We define the original function to be f of x and the inverse function to be f inverse of x. It says f to the negative 1, but that doesn't mean it's an exponent of negative 1, which traditionally means a reciprocal. We literally just read it as f inverse of x, but we write to the negative 1. Here's an example. Given a function f of x equals 2x, which takes each input and then doubles it to create the output, find the inverse function f inverse of x. First, notice how f of x equals 2x behaves with the inputs x equals 3 and x equals 5. If you plug 3 into the function, it's 2 times 3, which is 6. It doubled it. If you plug 5 into the function, it's 2 times 5, which is 10. Again, it doubled it. Thus, input 3 becomes output 6, input 5 becomes output 10, and the inverse function should do the reverse. If you input 6, it should become the output 3. And if you input 10, it should become the output 5. The inverse function must be inverse of x equals half of x, which halves each input to become the output. Halving is the reverse of doubling. Let's look at the tables of an inverse and the original function. Notice how the pattern of inputs and outputs are truly reversed for the following function, f of x equals x squared plus 3. Here's our original function. And the inverse, f inverse, equals the square root of x minus 3. First, take a look at the table of values for our function x squared plus 3. If you input the number 1, it's 1 squared plus 3, which is 1 plus 3, or 4. If you input 2, then 2 squared plus 3, which is 4 plus 3, which is 7. Input 3, 3 squared plus 3 is 9 plus 3, which is 12. And if you input 5, 5 squared plus 3, which is 25, plus 3, which is 28. So, in our original function, input 1, output 4, input 2, output 7, input 3, output 12, input 5, output 28. Now let's look at the inverse. I claim the inverse is the square root of x minus 3. So now I will plug in the outputs as our input, and theoretically it should give us back our original inputs. So let's try. If we plug 4 into our inverse function, the square root of 4 minus 3, which is the square root of 1, or 1. We plug in 7. The square root of 7 minus 3, which is the square root of 4, which is 2. I plug in 12, the square root of 12 minus 3, which is the square root of 9, or 3. And plug in 28, the square root of 28 minus 3, which is the square root of 25, or 5. As you can see, the inputs and outputs in the inverse function are in the reverse order of the original function. This reversal of order of inputs and outputs is what mathematicians mean when they speak of an inverse function. Some inverses are easy to figure out in our head. For example, the inverse of doubling is halving, and the inverse of adding 5 is subtracting 5. But how do we find the inverse function of a more complicated function, such as f of x equals 3x minus 5? Here's a definition. In order to find the inverse of a given function, first use y equals instead of f of x equals. Second, switch the y and x variables. Third, solve for y. The result will be the inverse function. Here's an example. Given the function f of x equals 3x minus 5, find the inverse function. So we'll follow our steps. First, rewrite the function with a y equals instead of an f of x equals. And here it is, y equals 3x minus 5. Second, and this is critical, switch the x and the y variable. So you'll notice in this expression, the y became the x and the x became the y. Third, we'd simply solve for the y variable. So I have my y variable on the right being multiplied by 3 and subtracting by 5. So I add 5 to both sides, giving me 3y equals x plus 5. Y is being multiplied by 3, so I divide by 3 on both sides, and I'm left with y equals x plus 5 over 3. That is the inverse function. And if you create a table of values for the original function, and you create a table of values for the inverse function, you will see that all of the input and outputs are exactly reversed. That is what we mean by an inverse function. Here's another example. Given the function x squared plus 3, find the inverse. We follow our 3 steps. First, rewrite the function with y equals. So I wrote y equals x squared plus 3. Second, switch the x and y variable. So x substitutes for y, and y substitutes for x. Third, we solve for y. So in this expression, y is being squared and added by 3, so I subtract 3 from both sides, giving x minus 3 equals y squared. Now, y is being squared, so I square root both sides, and I'm left with y equals the square root of x minus 3. This is our inverse function to the original function, x squared plus 3. Again, if you make a table of values with inputs and outputs for f of x, then the table of values for f inverse of x will be exactly reversed. Here are some practice problems. Find the inverse of the following functions. Go to the next screen when you're done and check your answers.